Hi. So I got cut off, sorry, but we're going to go ahead and look at the second example right here. Okay, so I have another sheet. So this one is giving you the mass and it's giving you the acceleration to calculate the force. Okay, so again, we're going to look at the same formula. So Newton's second law, force is mass times acceleration. So this is what we're looking at right here. Okay, so but in this one, we're given an acceleration and we're given the mass. Okay, so my acceleration is going to be 4 meters per second squared, and the mass is 300 kilograms, and we are going to be calculating force. Okay, so this is Newton's second law. So the amount of force we can calculate by the acceleration and the amount of mass that we have. So 300 times 4, which is going to give us 1,200 newtons. Also, just fun fact, okay, so 1 Newton is the same thing as kilograms times meters per second squared. That's what that unit means. Okay, so kilograms times meter per second squared, which is the reason how in the last example we were able to take newtons divided by kilograms and get an acceleration unit. So newtons, sorry, this is really hard for me. Okay, there you go. So 1,200 newtons newtons is that unit in force is kilograms times meter per second squared. But 300 times 4 gives us 1,200 newtons. So that's the amount of force that we're able to calculate from that. Okay, so again, Newton's second law just means that the amount of acceleration that we get is dependent upon the force that's applied to it and the mass as well. Okay, all right, so let's look at something else that's important. Oh, hold on, go back. All right, so one thing that's important before we look at this, hold on, let me go back. Okay, one thing that's important for us to know about Newton's second law is that it's really net force. Okay, so when we talk about net force, when we talk about an object, there's all kinds of forces that is applied to that object. You've got gravity, which is going to be acting down. You have friction, which always acts in the opposite direction of motion. And then you have like an applied force. So if I were to give you a picture of something like this, where we have like, let's say I'm going to draw a box right here. Let's say that it has a mass of 10 kilograms. And it has being pushed with an applied force of, I don't know, let's say 5 newtons. It also has gravity acting down on it. Okay, so let me draw you a free. Actually, hold on. I'm just going to, sorry, I know this is confusing. I'm trying to do this. So let's say we have applied force here is equal to 10 newtons, and then we have FF, or friction force, is, let's say, 5 newtons. Okay, if I were to give you a picture, or if I were to show you something, you cannot see that at all. Okay, here we go. So let's just say that I have a box right here, and FA stands for applied force. So that means that I'm pushing with a force of 10 newtons. But let's say that friction is opposing that. So let's say that it's sitting on carpet. So friction is in the opposite direction of motion. So you can see here that this is 5 newtons. So I'm pushing with 10 newtons, but I have an opposite force of 5 newtons. So my net force is going to be 5, because these are in opposite directions, so they're going to take away from each other. So I would have 10 down here, I have 5. So 10 minus 5 means that I have a net force of 5 newtons. Okay, so F net is equal to 5 newtons. It's really important when we're talking about Newton's second law to understand that the amount of acceleration that you're going to get is based on net force, not just force in one direction. So you have to calculate net force to figure out what the acceleration or the mass is. So really, a better formula for Newton's second law would be F net equals mass times acceleration, because that's a common misconception. Okay? So let's look at this right here. Let's say that I have let's say that I have a box right here. Let's say that F net is equal to 25, or I'm sorry, no, let's say F applied is 25 newtons. And let's say that friction force is still equal to 5 newtons. So the first thing that we have to do is to calculate F net. Okay, so in this case, so I've